Welcome to qnawire.
Okay, so we're doing chapter 34, problem 39 here. So this problem, it says we have a diverging lens with a focal length of negative 48 centimeters, negative because it's diverging, of course, and it produces a virtual image with a height of 8 millimeters at a distance, not 12, at a distance 17 centimeters to the right of the lens. And we're going to define this as a negative value. And what this means is that if our object distance comes out as negative, then if they're both negative, then on the opposite sides of each other. If the image distance is negative and the object distance is positive, they're on the same side as each other. In this case, will be the right, because this image distance we're defining on the right side of the lens. Okay, so what it asks us to do is find the position and size of the object. So that's S and Y. And then we want to see if the object and image are on the same or opposite side, if the image is inverted or erect, and draw a principal ray diagram. Okay, so we have all the information we need right here to just start plugging and chugging with our thin lens equation. So let me write this out. Now if we rearrange for S, solving for object distance, we can see that this is S prime F over S prime minus F. Now we can just plug our stuff in. And then negative 17 plus 48 here. If you plug all that in your calculator, it's pretty easy. We should see that this comes out to 26.3 centimeters, and it's positive. So just as I said before, this object distance is positive, meaning it's on the same side as S prime, the image. So this means this is the right of lens, same side as image. Cool. So now we know the object distance, but we still need to get the object height. So to do that, we know that the magnification is negative S prime over S, or Y prime over Y. We rearrange this, we can solve for Y. That means Y is now negative Y prime S over S prime. If we plug all that in, we should see that this becomes 12.4 millimeters. And this is positive, so that means it's not inverted, it is erect. It's the same upright image. So now, yes, we have the image size and the image location. So these should fit everything we need, and now we can check our answers we got through this lens equation graphically with our principal ray diagram. So that's what we're going to do now, is draw our principal ray diagram. So let me go ahead and draw this diverging here, draw it nice and big here. With our big axis through it. Let's put some focal points on here. Let's call this F1, the left focal point, F2 here, the right focal point. So the focal points are at 48 centimeters away. So for the object, it said we ended up saying 26 centimeters, so a little bit over halfway. So I'll make this the object. And now we want to find where the image is. So let's, I'll do in different colors here, the three different types of principal rays here we can draw. The first one comes out parallel. And then when it hits the diverging lens, it diverges as if it came from the left or the right focal length. So out like that. Cool. The second one is nice and easy. It just goes straight to the center and is not refracted at all. Cool. And then the last one, it goes like it's going to go through the left focal point, so down here, and then gets refracted parallel. Let me make sure I show you where these change. There's not much of a change right there. Cool. So what we can do is we can trace this guy back here, and we should see where they all cross right about here. And I'll fill in the image in black. This being our image and this being the object. Cool. And that's everything. If we can double check things, we see that it makes sense. Our image is shorter, upright, and closer to the lens, and also on the same side. So everything checks out perfectly as our numbers did.